So far, each page in this module has just gone over one step of the ANOVA F test. But now we'll do all the steps in one example, just so we have a good feel for it overall. We'll walk through a full example of a hypothesis test for the differences among 3 or more population means using the ANOVA F test. The example talks about reading levels for target audiences. The question is, do advertisers alter the reading level of their ads based on the target audience of the magazine they advertise in? In 1981, a study of magazine advertisements was conducted. Okay, and then a lot of details about that study. Researchers selected random samples of 18 advertisements from each of these 3 groups of magazines. Group 1, highest education level magazines such as Scientific American, Fortune, the New Yorker. Group 2, middle education level magazines such as Sports Illustrated, Newsweek, and People. Group 3, the lowest educational level magazines such as National Enquirer, Grit, True Confessions. To access the reading level of the ads, researchers counted the number of words in the ad. The following figure summarizes the problem. Let's go down and look at that. Okay. So higher education levels off to the left. Oops. Here they have a mean of mu1, medium education levels off in the middle, low education levels on the right. All the sample sizes are the same, 18, 18, 18. And then we have sample means, the number of words. So for higher education levels, there were about 140 words on average when they took the sample of 18 ads. For the magazines that were geared toward medium education levels, there were 121 words. And then for the lower education level magazines, there were 106 words on average in the samples they took. So there were 3 samples. That means we need to use the ANOVA test. We can only use the previous test that we know about if there were 2 or fewer, 1 or 2 sample means. But now we have 3 samples. So, okay, we need to determine if the differences in the sample means are statistically significant. In other words, are the differences among the observed sample means due to true differences among mu values or simply due to sampling variability? First, we'll state the hypotheses so that the null hypothesis, like we said before, is that all the population means are the same. Mu1 equals mu2 equals mu3. If there were more than 3 populations we were trying to compare, we would have a mu4 and on, but we only want 3. The alternative hypothesis is that the mu values are not all equal. So at least one of those is not the same as the others. Maybe all 3 are not equal, but for sure, at least one of them is different, according to the alternative hypothesis. There's another way to view these hypotheses. The null hypothesis claims that the number of words in ads is not related to the education level of the magazine, that they should be all equal on average. The alternative hypothesis claims that there is a relationship. The second step will be collect the data and check conditions. First, the ads were selected at random from each magazine group, so the 3 samples are independent. Second, we do not know the shape of the distribution of word counts in the population of ads for the 3 types of magazines. In addition, the sample sizes are small, n equals 18. They're supposed to be greater than 30 in order to use the test that we would like to use. Therefore, we need to look at the shape of the distribution of word counts for each of the 3 samples to see if we think the samples come from ad populations with a normal distribution of word counts. The graph does not display any alarming violations of the normality assumption. There's some skewness in groups 2 and 3 below, but the skew is not that extreme and there are no outliers. Let's go down and look at them. Yeah, I don't see any individual, with box plots, you would see individual dots for outliers, but I don't see any of those. Those are all, yeah, that's fine. And it looks like they're all 3 fairly sort of toward the middle. They're not like super close to the larger values or super close to the smaller values. They're basically all in the middle, maybe a little bit closer to one side than the other, but I think they're all pretty normal. I'm going to put approximately normal for all 3, no outliers like it said. Okay, now we need to verify that the standard deviation in word counts for the 3 population of ads is the same. We do not have information about the population standard deviation, so we look at the sample standard deviations to determine if they are close. The rule of thumb is that the ratio of the largest standard deviation to the smallest standard deviation is less than 2. So the group 1 standard deviation was 74.0, group 2 standard deviation was 64.3, group 3 standard deviation was 57.6. We can assume that the equal standard deviation assumption is met since the rule of thumb is satisfied. The largest sample standard deviation came from group 1, that was 74.0. If I divide that by the smallest, which is the bottom one, 57.6, I should get, it's about 1.28, which is definitely less than 2. Okay. So yeah, as it says, it's less than 2. Before we move on, let's look again at the graphs. If you scroll up and look at the graphs or down, depending on where you are on the page, the sample means are marked with red dots. The differences in the sample means are dwarfed by the large amount of variation within each of these samples. We see this in the overlap of the box plots. So the boxes are very tall, all three of them. They vary quite a bit. They overlap if you look at them horizontally compared to each other. This suggests that the differences in the sample means could be due to chance. In other words, the graphs could come from populations with the same means, but we need to conduct the ANOVA test to draw this inference. The third step will be now assess the evidence with a p-value. So we'll use StatCrunch to conduct the ANOVA test, the ANOVA F test. We'll find that the F statistic is 1.18, which is fairly small. That's not a good sign if we want to reject the null hypothesis. The p-value is 0.317. If the 3 magazine groups have the same mean word count in their ad, in other words, the population means are equal, then sample differences in mean word count larger than those observed in the samples is fairly common. It happens about 32% of the time. Therefore, we conclude that the differences observed in the sample means are due to chance and do not provide compelling evidence of a difference in population means. So we won't be able to reject the null hypothesis this time. So now we'll state the conclusion. Okay. The large p-value indicates that the results are not statistically significant because p, what was it? It was 1 point something. So anyway, p was 1 point, yeah, whatever, 1 point something less. That's definitely, greater than 0.05, which we were assuming alpha would be. So we cannot reject the null hypothesis, and we cannot conclude that the population means differ. The study does not provide compelling evidence that the mean number of words in ads is related to the education level in the magazine. In other words, the study does not provide compelling evidence that advertisers alter the reading levels of their ads, as measured by the number of words based on the education level of the target audiences in the magazines.